Alrighty, so we're looking at the curve y equals x squared, and I've picked a point on it. So I've picked the point 2, 4. Now you've got the graph of y equals x squared in front of you. You can just mark the point and call it P, sorry. Okay, so label it P. Now what I'm going to do is I'm going to pick another point on the curve. So I'm going to pick 1, 1. Okay, and I am going to join 2, 4 and 1, 1 together. Okay, I'm trying to find the gradient of my parabola at the point P. Okay, now this is looking pretty good, right? I can make my triangle and I can find my run is 1 and my rise is 3. Okay, so I could come up with a gradient of 3. What do you think? Does that seem okay from what I've done? Okay. Now, this looks all well and good, but what I'm going to do now, you can see that I've kind of deceptively zoomed out. I'm now going to zoom in. Okay, so can you see how this is starting to look like a problem now? It didn't before. Whoa, could we even get more inaccurate? Okay, so tell me, how could we make this gradient more accurate? So the gradient is not 3. Okay, so at the point 2, 4, the gradient is not 3. Luke, what could I do?
Have points that are closer together.
Okay, I could choose a point that is, thank you, that is closer than 1, 1 to 2, 4. Does that make sense? Okay, remember how we talked about that limit as h approaches 0, that h is our difference in the x values. We want it to be as small as possible. That's what we're talking about here. Okay, so
1.5 and 3.
let's come back. We're going to go even further than that, Luke. So we're going to have a look and say, all right, what about when the x value is 2.1, okay? So the x-coordinate is 2.1. Now, I know that my equation of my graph is y equals x squared. So would you be happy that the y value is 2.1 squared? Yes. Yeah? Okay. Now, we call that line that was drawn on the graph joining P and Q a secant. Okay, you would have seen secants in circles, okay, but we call that a secant, and we're finding the gradient of the secant at the moment, okay? So remember the gradient is y2 minus y1 over x2 minus x1, right? So my y2 is 2.1 squared, yeah? Now remember my point P is the point 2, 4. So that's my x1 and y1, yeah? So I've got y2 minus y1 over x2 minus x1 is 2, okay? And if we calculate that, let's have a look at what we come up with. So you can see that I'm looking really close to the point now. I'm only 0.1 away with my h. I'm just going to type that as 0.1, okay? So my gradient, it says, is 4.1, okay? But do you know what? Damn, it's not the time. Let's be even closer than 2.1. Let's go for 2.01. That's pretty crazy, you're right, okay? It's so close.
Bogus.
So my y value then is going to be 2.01 squared because this is the curve y equals x squared, yeah? And so I'm going to do y2 minus y1 over x2 minus x1, which is going to look very similar . And I could just sneakily go and put some zeros in here. Okay. Interesting. interesting. Okay, let's go get even closer. Let's just go for it. 2.0001.
Wow.
Bet money's gonna be 4.0001.
Really? I didn't think that.
I'm not gonna write the substitution for that one down. Okay. Now, let me just clarify what I've done, okay? So I've come and, let's get rid of Q, okay? I've come and I've looked on this side of my point. Does that make sense? So I'm looking at 2 and a bit. So I'm trying to do one that's like, it's even closer than that. Does that make sense? Yeah? So I've looked from that side. I'm now going to come from the other side. Is that okay? So we're going to fill out that other table. But instead of going for just a bit more than 2, we're going to go for exactly a bit less than 2. So I'm going to go for 1.9 as my x value. Yeah? And so that means my y value is going to be 1.9 squared. I don't really want to rub that off, but I will. So we've got y2. This one is going to be your y2 this time. It doesn't really matter because the negatives will cancel each other out if you did it the other way around. I guess I just think of the higher point is usually the one I go for. So I'm going to do 4 minus 1.9 squared over 2 minus 1.9.
Does it matter to you? What do you do?
No, you'll get the negatives will cancel each other out if you did it the other way. Okay? And this is 3.9. Interesting. Is this interesting? It is.
Yes,
It's very interesting. Okay. I'm getting a little bit impatient, so I'm just going to go straight to 999, okay?
Oh, wow, that's a big.
Well, it's not really, is it? Okay.
I'm guessing that's 3.9.
So now we have 3.999. Okay, now let's have a look. On this side we had 4.1, 4.01, 4.001, okay? When we're coming from the right, so when we're looking at one like this, okay? When we're coming from the left, we're looking at 3.9, 3.999. Okay, we're trying to get more and more and more accurate. So what would you say the gradient of this curve is at the point 2,4?
4.
It's 4, right? Can you see how it's approaching 4 from both sides? Yeah? Can we see that?
Yes.
Okay. Yeah. So if I made these even smaller, I'd get even closer to 4 and even closer to 4. And that's why we want our h to approach 0, okay, so that we actually get to 4, okay? Now, let's have a look. I've lost my mouse, sorry. Let me get it back. Okay, so if we have a point, I'm just going to put my Q up here, okay? Remember that the gradient is rise over run. Now, I'm focusing on the point 2, 4, right? Now, we've called our distance that we move across, our run, h, okay? And so, what's the x value of my point Q?
2 plus h.
Okay, so I'm at 2 plus h because I moved along h from 2. And this y value here is 4 because it's the 0.24. Okay? How do I find this y value here? Not Pythagoras. I don't know the hypotenuse. Substitution of what? What do I sub? Okay, so I sub that x is equal to 2 plus h. Are we happy with that? Okay, so what I'm finding is f of 2 plus h. Would you agree with that? Yeah? So this is going to be f of 2 plus h, which just means sub 2 plus h into the equation. Okay, careful, it's 4h, 2h, and then double it. Yes, easy mistake. Okay. Alrighty, so we've got our gradient, and we want our h, remember, to approach 0, yes? Okay, and so we're looking at y2 minus y1 over x2 minus x1 What are we going to do here?
Factorize.
Okay, factorize. And now we substitute. So h is 0, and so the gradient is 4. Now, remember how we did all that work in the table? We approached from both sides and the gradient was 4? Yeah? Well, this is, it doesn't feel that quick, and it will get much quicker, don't you worry. But this is a quicker way, rather than having to approach from both sides, of finding the gradient of the tangent to the curve at that point. Rachel?
But I thought we said the gradient isn't constant.
No, it's not. And the reason, that's a really, really good point. So the reason we've come up with a constant here is because we've used a specific x value. So what we did in a previous question was we came up with the gradient was 2x, yeah? And what's 2 times 2? It's 4. So it's just because we've used a specific x value. So we've looked at that particular point, okay? But that's a really good point. So we're looking at approaching 4. Whoops. Okay, so we want to make this, can I rub that off? We want to make this general now, okay, because we've done this for a specific situation. And we did kind of already come up with this, okay. Hopefully you're feeling like this is a little bit repetitive, because I really want you to understand what we're doing when we differentiate. So if I've got my 2 points P and Q, okay, I call my point P X, Y, but remember instead of Y I write F of X. And I've got my X value here, which means my second X value is X plus H, okay? Which means my second Y value is F of that, yeah? Sub this X value into Y to get, into the equation, sorry, into F of X. So this is F of X plus H, okay? And then remember we talked about the change in Y, the change in X, or Y2 minus Y1 over X2 minus X1. Okay? And so we say that that is y2 minus y1 over x2 minus x1. Okay? And how did this simplify? Does the top simplify? No, it does not. But what happens at the bottom?
You get H.
Okay, we just have h. Now, here's the thing. This is a little bit dodgy. What's dodgy about what I've done here? What's missing?
Everything.
You changed f of x to f of h.
Oh, sorry, that was not intended to be dodgy, but it was. Okay, Josh? The limit. Okay, so here's the thing. How big is h? Okay, this is quite inaccurate when h is large. And when I say large, like h being 1 is way too large. Like h needs to be 0.000000. Like it basically needs to be 0. That's why it's the limit, right? So actually, we want h to approach 0. And so that is called differentiation from first principles. Now, unfortunately, you need to remember this.
Is it on our formula sheet?
I am saying no, but I'm going to check again because I feel like I keep getting confused. Has anyone got their formula sheet handy? So I am pretty confident it's not there. So yes, it is interesting. It is quite easy to derive. So I hope that gives you some confidence that it's not some really abstract thing for you to memorize. Okay? So we are going to keep going, and if we get through this lesson and you're away next week, you will not miss new content. I am going to teach some things that I'll repeat next term. Okay? So hopefully that makes you feel a bit better. Okay, so team, we've already done this. Okay? This is what we just did.
Find the gradient of the tangent to the curve.
That's it. We're finding the gradient
You say
of the
faster, it makes it
tangent
smaller.
to a curve. Now we're starting by doing something called differentiation from first principles. If I'm going to show you a really easy method to differentiate, this is not it, okay? So if you use the easy method when the question said differentiate from first principles, how many marks do you get? 0. Okay, so it's the limit as h approaches what?
0.
Okay, and remember it's y2 minus y1. Okay, so that was, what was the y2? F of x plus h, and y1 was, okay, and then we have x plus h minus x, which the x's cancel out. So I'm just going to write that as h, but that's where it came from, right? It is still x2 minus x1. Okay, I'm going to rub it because it's on the next slide and you can see it if you're still writing it, okay? Okay, so I can tell you, you ready? Don't be too impressed. Can you get rid of that, please?
Sorry.
I can tell you that the answer to this is 2x. Just like that. Because I'm a genius. No, it is 2x, but I am not a genius. What we want to do, to start with, is work out what is f of x plus h. Okay, so write a bit of a list. You know what f of x is. How do I find f of x plus h? Substitute what, Rachel? Okay, so replace x with x plus h. Okay, you'll find it can become a little complicated. Okay, at times. This one's not too bad, the next one's not as nice. Okay, so I found f of x plus h. Now I'm going to go and actually find what I was asked to find, which was this. So this question could have said differentiate from first principles, but it gave me the formula. The limit as h approaches 0 of f of x plus h
Oh,
minus f of x.
Wouldn't it be minus x squared plus minus 3?
Okay, so we need to make sure we're subtracting the whole of f of x, right? Now, whether you put brackets around this or if you just write it as the minus the first time. Okay, and so now what happens that's quite nice?
It's now 2xh plus h squared.
Okay, so we've got x squared minus x squared and 3 minus 3. And so we have 2xh plus h squared over h. And what do we do now?
Factorize.
We factorize.
You are a genius.
So the limit is 2x. No, the gradient is 2x.
Magic, right? I'm basically a magician, just saying.
Magic.
3x.
Okay.
3x.
It is 3x squared plus 1. Okay, the next one. Find f of x plus h. This one is not as nice. Okay, so we want to find x plus h cubed plus x plus h. Okay, so every x needs to be replaced with x plus h. Reminder, extension, that you do have other methods of expanding. Okay, if you remember. I'm not going to use
The
that.
guy's triangle.
Pascal.
With Pascal's triangle, that's right.
I prefer Pascal's pineapple one.
So the way I'm going to do this, thanks team.
It tickled my stomach.
The way I'm going to do this is, just waiting. The way I'm going to do this is by keeping one of the x plus h's, and then I'm going to expand x plus h all squared. Is that okay? So I'm going to do x squared plus 2xh plus h squared. So this is x plus h, this is x plus h all squared. Okay? So now I'm going to carry that x through, just saying that like immediately I knew what the answer to this was. You can see there's quite a lot of work involved in this, so our quicker method is much quicker, but we'll get there. Okay, so extension, you could have used your expanding to come up with the extension straight away, right? Remember 1, 3, 3, 1. So x cubed, gotta find my like term, so that's 3 x squared h, x h squared. If you're not doing extension, you're not at a disadvantage. It's a slightly quicker method of coming up with it.
That is just for f of x. Plus h.
Okay, and then plus h cubed plus x plus h. Whew. And guess what? We're not done because we haven't actually substituted into the limit yet, have we? Okay.
Yeah.
But if you're expanding a cubic, I would keep one bracket and expand to the power of 2, okay, and then distribute into that. Okay, so now I'm going to find my limit as h approaches 0 of this. Minus f of x. So that's minus x cubed minus x, right? All over. It looks so bad, doesn't it?
Yes.
Thanks for the support.
Is that the answer that you got, Vicky?
Team, look, I'm not going to write this, I'm going to take the h out in this step, right, because this is annoying to keep writing such a long expression. So I'm taking the h out. I've cancelled x minus x is 0, x cubed minus x cubed is 0, and you'll find that this happens because it works perfectly. What happens when I take out h from h?
Becomes a 1.
Okay, it's a 1. Emily? This one, so what I've done here is I've done f of x plus h, which is that whole bit there, and I've taken away f of x. So I've done the negative of both of those terms. Does that make sense? Okay, what am I going to do now in my next step?
Substitute.
Substitute that h is 0. So that gets rid of these two terms, doesn't it? And it's exactly what Horace said it was in the beginning, which is 3x squared plus 1. Because it's very easy to work out with the easy method. But if you're asked to differentiate from first principles, then you must. Okay? So the gradient of the tangent to the curve at any point on this graph, x cubed plus x, is equal to 3x squared plus 1. Now, Rachel said before when we looked at the parabola, why have we come up with a constant? It's because we looked at a specific point. So if we were to sub in x equals 1, we would find that the gradient of the tangent to the curve at x equals 1 is 4. We would come up with a number for it. Okay? So what we're finding is the gradient of the tangent to the curve. I might actually just bring that curve up. Okay, so we've got y equals x cubed plus x. And when we differentiated, what we found was the gradient of the tangent to the curve. So if I choose a point, okay, like I said, if I choose where x equals 1, and I draw a tangent at this point, okay, the gradient of this line, this is my gradient here, at x equals 1, my gradient will be 3 times 1 plus 1, it will be 4. That's the gradient of this line, right? Okay. If I have a look at my gradient over, let's say here, at negative a half, what can you tell me about the gradient at negative a half? Is it positive? Is it negative? Look at the line.
9.
Okay, it's positive. Is it steeper or less steep than my gradient at x equals 1? Okay, it's a flatter line, so this one is more steep. So if I sub in that x is equal to negative 5, you can see how, even though there's a negative, I'll get a positive because it's a squared, right? And so the gradient at that point is, I think it's 7 over 4. Sorry if I've made a mistake. Okay. So that's 1 3/4. So it's less steep. Okay. That's what we're finding as we differentiate.
Miss,
Yes.
can Ryan have a book?
No. Okay.
You can copy mine, Ryan.
So, differentiation from first principles, write the formula again. Okay. So you might be asked to differentiate. You might be asked to
Good idea.
find the gradient of the tangent to the curve. You might be asked to find m because that's the gradient. You might be asked to find, remember how we talked about the change in y over the change in x, and we wrote it as the delta, right? We actually usually write it as dy over dx, okay? And this means change in y, change in x. It's a d, it's not a delta there.
As in, but like it means representing delta.
Yeah, it means change, yeah. So we might write it as find y dash. Means the same thing. We might write it as, not fin, find f dash of x. All of these things are the same. They're all the same. The dash is the derivative. Okay? So here you've got the gradient of the tangent to the curve when we're using first principles is what we've just been using. Okay, and I'm taking my first video of a lesson so you can have this, what I suspect will be extremely dodgy recording.
Ryan, you missed her joke.
I appreciate it.
Miss, Ryan's not going to get to appreciate your joke.
Oh, the limit joke, because I started recording like after I'd made my joke. And it didn't show how hilarious I am. Okay, so
Just make the joke again.
Have a limit.
we're going to have a look. Actually, I think we'll just go and do this last one here. So let's just skip over Joel.
Saying use the result and have first principle. Is that like saying use first principles?
Yes, use first principles.
So I
Yeah.
can't
No. I mean, the whole point of this lesson is to differentiate from first principles. Okay. Oh.
Yeah, that's good.
Do you know what would be really helpful? Is if I gave you a curve. Okay. All right, team. This is going to be the last example. Thank you. Yeah, we missed a slide. Okay, we're going to leave that one. It's just the same as what we've done. And my apologies, in this question I haven't given you an equation. So this is the curve that the question's referring to that I've just made up. Okay? So we want to find the gradient of the tangent to the curve at the point where x equals 1. Now, normally, because it doesn't say from first principles, we wouldn't do it in this way. But we're learning that at the moment. So we're going to do it from first principles. Okay? So we know f of x, but we need to know what? Okay, f of x plus h okay, you go ahead and expand and simplify, and then go and put that into your formula.
Okay, you haven't been paying attention to this. Wait, so the lim, what's the lim then? Is it x approaches
Minus
1
2x
on
squared
h
plus
plus
5? Yes, we do.
So the limit will always be as h approaches 0, because the limit is not about x, right? Because h is that difference between the two x values, which we want to be infinitesimally small.
Yeah.
Yes, you could just sum.
4hx plus 2h squared.
Because we make h equals 0.
Why is it always
So that's why you do it. You keep h in 2, isn't it?
2x
So, I'm-
or perhaps
in first principles, so we're not expanding, because expanding the cubic was a bit annoying, right?
No, why is it always equal to 2x or yeah?
Well, this
In
one's
this
going to be equal to 4x, right?
But that's because it's 2x squared, isn't it?
Yes, that's right. So we're going to talk about that next week and next term. So note that I subtracted the whole thing, so that means negative 2x squared, positive 5.
It is.
Okay, 2x squared minus 2x squared is 0. Minus 5 plus 5 is 0. I'm going to take my h out.
Weird stuff.
And I cancel, like it's very repetitive, right? We end up doing the same thing. I'm now going to sub that h is 0 and I get 4x. Now, this isn't actually my answer though. Why is that? So I'm looking at x equals 1, right? So that means my gradient is 4. Okay, now, Jamila said, or I'm not sure if this is what you were asking, could we have substituted at the beginning? Is that what you were asking? No? Okay. Well, we could have, right? So alternatively, because we had this x value is 1, we could have said f of 1 and found that is negative 3. F of 1 plus h, we'll have to expand this, so there's still a bit of work involved, right? So I might just try and go with, I'll replace all my x's with 1s. Okay, so maybe then I can sub into the formula. Maybe it was a little bit simpler. Okay, so you could have sub first. I probably wouldn't suggest doing this because it can get confusing later on, because later on we don't do it. So I would go this way just to keep consistent. Okay? Alright, so what we are going to do now is turn off the video.